Assalamu alaikum. Today I will be presenting about one of the most tragic industrial pollution cases in history, the Minamata Mercury poisoning in Japan. This case is not only about chemistry or industry, but about ethics, responsibility, and human suffering. It shows what happens when engineers forget its hearts. From 1932 to 1968, the Chizo Corporation, a chemical factory in Minamata, Japan, dumped around 27 tons of methylmercury into Minamata Bay. Mercury was used as a catalyst in the chemical production process. Instead of treating the wastewater, it was directly discharged into the sea. This toxic compound entered the marine ecosystem, poisoning fish and shellfish, which is the main food source for the local fishing community. At first, no one realized what was happening until people started getting sick. The first signs appeared in 1956 when residents began to suffer from unexplained illnesses like convulsions, blurred vision, trembling hands, and difficulty speaking. Doctors call it a mysterious disease. Eventually, scientists identified it as methylmercury poisoning. Tragically, the mercury didn't just affect adults, but it crossed the placenta, causing severe birth defects in babies. Over time, thousands were affected, while families suffered, and the disease became known as Minamata disease. The Minamata disaster is a powerful lesson about how pollution occurs through nature. Let's break down three key environmental concepts. First, bioaccumulation. This means that toxins like mercury build up in individual organisms such as fish or shellfish over time. Biomagnification. As those fish are eaten by larger predators and then eventually by humans, the mercury concentration increases at each step. Legacy pollution. Even after Chizo stopped dumping, the mercury stayed in the base sediments for decades, poisoning the habits. The human impact was devastating. For health crises, many victims suffered permanent brain damage, hearing and vision loss, and paralysis. For societal trauma, these victims face intense stigma. People avoid them out of fear. Children born with deformities were hidden or isolated. For human cause, it wasn't just one generation. The damage continued in the children born years later. Minamata became a symbol of how one industrial mistake can destroy the entire community's health and dignity. The disaster also had a huge economic impact. The local fishing industry collapsed, destroying livelihood. The healthcare system was overwhelmed with long-term treatment and care cost billions over a year. Massive clean-up operations were needed to remove contaminated sediments and restore the bay, an expense shared between the government and Chizo Corporation. This shows how preventing pollution is always cheaper than repairing the damage later. Now, let's talk about the ethical failures behind this tragedy. For corporate responsibility, Chizo knew mercury was toxic but prioritized profit over safety. For justice, the victims were mainly poor fishing families and powerless to fight a big corporation. For transparency, both the company and local authorities hid information and delayed action, worsening human suffering. As engineers, this challenges us to ask, who pays the price when we ignore ethics? So, How can we prevent something like Minata from happening again? The answer lies in green engineering designing technology that protect both people and the planet. For non-toxic catalysts, replace dangerous chemical like mercury with safer alternative. For designing safety, engineer processes to eliminate hazardous byproducts right from the source. For life cycle assessment, known as LCA, before launching production, test how materials will impact the environment throughout their entire lifespan. It's about responsibility at the design stage, not the disaster stage. For existing contamination, engineer can help with remediation methods. It's a ways to clean up toxic waste. For phytoremediation, use plants to absorb and store metals like mercury from soil and water. And for safe dredging, removing contaminated sediments carefully to avoid spreading toxic furthermore into the ocean. As you can see the diagram, it shows it's showing how plants can absorb and break down pollution. This is nature and engineering working together for recovery. In the long term, industries need sustainable chemical design. First, closed-loop manufacturing. Recycle wastewater internally so nothing toxic leaves the factory. Next, advanced filtration. Use modern membrane or absorption system to trap heavy metals before disposal. When systems are circular rather than linear, pollution doesn't escape into nature. Minamata connects directly to several United Nations Sustainable Development Goals, SDG 3, good health and well-being, regular health monitoring for communities near industrial zone, SDG 6, clean water and sanitation, strict zero discharge policies to keep our water sources clean, SDG 11, sustainable cities, creating green buffer zone between factory and residential area. For urban strategy, developing safe system for disposing of mercury-containing products. SDG 12 Responsible Consumption and Production. Following the Minamata Convention to globally phase out mercury and holding companies accountable for the waste. Every SDG reminds us that safety, health, and sustainability are non-negotiable. In conclusion, the tragedy of Minamata is haunting reminder that engineering must have heart. When we prioritize profit over safety, it is our neighbors and their children who pay the price with their health and their future. As future engineers, our mission is to be protectors, not just problem solvers. By committing to green engineering and the SDGs, we ensure that our progress never leave a toxic debt for others to pay. Let's design a world where our innovations support the safety and dignity of every human life, but a promise that our progress will always prioritize the safety and the people we share this world with. Because true engineers isn't just about solving problems, it's about protecting people. This is the reference. You can search to know more information. I hope this presentation helped all of us see how important it is to think ethically and sustainably in every engineering decision we make. Thank you. That's all for me.